Well, welcome to what has got to be the most ridiculous setup for a math lesson. We've got three cameras going, and we've got two audios going. So hopefully the quality for this is decent, but we're going to go over PEMDAS. We're going to go over it quite in depth. And before we get started, I do want to rewrite the acronym a little bit differently here. Technically, the P is its own thing, parentheses, right? That always needs to be done first. And then followed by that is exponents, and that includes roots. We'll see some of those. But then the M and the D for multiplication and division, those bear the same weight, meaning we're just going to work those out from left to right. And the same is true of the A and the S for addition and subtraction. They bear the same weight, which means we just work that out from left to right, even if that means subtracting before adding. And that's what we're going to see in our first example here. So we're going to go over common points of confusion before we jump into full-length problems. And the first category here is when only addition and subtraction remain, evaluate from left to right. And just as I said, even if that means subtracting before adding, and that's exactly what we're going to have here. Yes, in this problem, you are supposed to do 5 minus 7 first. 5 minus 7 is -2, plus 1 is -1, and that is the answer there. Next one, left to right. All we have here is addition and subtraction, left to right. 3 plus 11 is 14. 14 minus 10 is 4, and 4 minus 9 is -5. That is the answer. At any point during the video, you're more than welcome to pause it and try to work out the problem before I do it. But I'm not going to stop. I'm just going to plow through all of these. But please, it's highly recommended that you try these on your own. Anyways, left to right, we start with -2 plus 6, which is 4, minus 4 minus 8 plus 12. Next is 4 minus 4, which is conveniently 0. So we just bring down -8 plus 12, and -8 plus 12 is 4. The answer here is 4. That was all three of those. Okay, so similarly, we're in the same category, the same topic. When only multiplication and division remain, evaluate from left to right. And yes, even if that means dividing before multiplying. I know in PEMDAS the D comes after the M, but it's okay to reverse those if it comes before from left to right. And that's exactly what happens here. If we work from left to right, we will divide before we multiply, and that is correct. That is what you should do. 12 divided by 4 is 3, and 3 times 7 is 21. The answer here is 21. Next, we have 20 divided by 5, which is 4. So 4 times 3 divided by 6. Next, 4 times 3 is 12, and 12 divided by 6 is 2. The answer there is 2. Left to right, 4 times 15 is 60. 60 divided by 6 is 10. 10 divided by 5 is 2. Times 11 is 22. Can you do more steps than one at a time? Sure. Just make sure you go from left to right. All right, here we go. The absolute value functions as parentheses in addition to its definition. So you may or may not know what the absolute value is. I'm not explicitly teaching that right now, but the absolute value informally makes everything positive. There's more to the definition, but that's all you need to know for now. You should also treat the absolute value as if it were parentheses as well, which, that's your P in PEMDAS. That's the very first thing. So when I'm looking at a problem like this, I'm going to treat this as if there were parentheses here. I need to do that first. So 3 minus 5 is -2. Now, don't ditch the absolute values until you've actually used them, which we will do now. The absolute value of -2 is +2, and 2 times 2 is 4. The answer here is 4. So again, treat the absolute values as if they had parentheses around them. 13 minus 6 is 7. And then the absolute value of 7 is, well, just 7. The negative goes along for the ride. And -7 minus 4 is -11. Last one in this category. Again, treat it as if there were parentheses here. We'll start on the inside with that 5 minus 11. 5 minus 11 is -6. Now we take the absolute value of that -6, which is +6. When we do that, we can switch to parentheses because we do still need to multiply, which is the next thing we're going to do, right? 4 times 6 is 24. The next thing we need to do is division. 24 divided by 12 is 2, and -1 plus 2 is +1. That's the answer right there. +1 is the answer to that one. There we go. That one was starting to feel like a full PEMDAS problem, but we're working up to it. In the same manner as the absolute value, any root also functions as parentheses. And then I did state this at the beginning, but the root itself falls under the exponent category. So we're going to evaluate what's underneath the root as if there were parentheses P, and then we will evaluate the root which falls under E, exponents. So starting with the first one here, 16 plus 9 is 25. And now we're going to do the square root of 25. And kind of like when we took the absolute value, once we apply that function, we can switch to parentheses. Square root of 25 is 5. We switch to parentheses, which means we multiply. This was multiplication all along. 2 times 5 is 10. That is the answer. Start with the radical as if there were parentheses there. So 36 plus 64 is 100. Next, we're going to do the square root because it falls under the exponent category. The square root of 100 is 10. The negative just goes along for the ride. And -10 minus 11 is -21. Start with the square root all the way on the inside there. So the first thing we need to do is 94 minus 13. And 94 minus 13 is 81. We have 3 things left to do: subtract, square root, and multiply, right? The next thing we need to do is the square root. It falls under the exponent category, and the square root of 81 is 9. Next, we multiply. 9 times 2 is 18, and -7 minus 18 is -25. The answer is -25. Same flavor of what we've been talking about with the absolute value and the square root. The entire numerator or denominator, I should say, and of a fraction is to be treated as having parentheses. So when you are facing a problem like this, treat it as if there were parentheses around the numerator and treat it as if there were parentheses around the denominator. So 10 minus 2 up top is 8. -1 plus 5 on the bottom is 4. And then you can divide. 8 divided by 4 is 2. Second example of this, treat the numerator and the denominator as if they had parentheses around them. So Up top here, a double negative becomes a positive, so this is negative 7 plus 10. In the bottom, we have 1 minus, and 2 squared is 4. Up top, negative 7 plus 10 is 3. In the bottom, 1 minus 4 is negative 3. And 3 divided by negative 3 is negative 1. Eight minus 20 is negative 12. In the bottom, we have 3 squared, which is 9. I'm going to do this in one step. 3 squared, which is 9, minus 7 is 2. Plus 3 times negative 2. 3 times negative 2 is negative 6. So notice here, I'm going to switch this from a plus to a minus 6. Negative 12 divided by 2 is negative 6, minus 6, and the final answer here is negative 12. So again, if you have absolute values, roots, or fractions with a numerator and denominator, make sure you simplify those pieces first as if they were in parentheses. Here we go. The use or lack thereof of parentheses may change the sign in the context of exponents. Again, I recommend you pause and try these. The point of these problems is to show you which ones are going to be negative and which ones are going to be positive. See if you can figure that out. Starting with the first one, we have negative 2 with parentheses squared. This is the same thing as negative 2 times negative 2. And the point here is that a negative times a negative is a positive. The answer here is positive 4. But compare this to the next fraction, the next problem, which does not have parentheses. This means that the negative is not being squared. So this is equal to negative, 2 times 2, which is negative 4, because there's only one negative this time. Put the last two problems together, and we have negative parentheses negative 2 squared. Well, the negative 2 with parentheses squared, that right there is the first problem, and we know that that is positive 4. I'll write it out anyways. We have the negative out front, then we have negative 2 times negative 2. Count how many negatives there are total in this problem, and you'll see 3, right? A negative times a negative is a positive, but times a third negative alternates. It switches it back to negative. So the final answer here is negative 4. What if we bump that up to a third power, right? How does that change? So this time it would be negative 2 times negative 2 times negative 2. Well, that's 3 negatives. And if you multiply 3 negatives, as we did in the previous problem, your answer is going to be negative. Make sure here it is 8. 2 cubed is 8. What about without parentheses? So this would be negative, and then separately 2 times 2 times 2. 2 times 2 is 8, and the negative just tags along for the ride. Here there's no difference. In the last problem there were 3 negatives. In this problem there was only 1 negative. In either situation, the answer will be negative. Last one here. This is negative 2 times negative 2 times negative 2. All right, how many negatives are there in this entire problem? Count them out. There are 4. And if you multiply 4 negatives, you're going to end up with a positive. Those are all 6 of those. Hopefully you picked up on a pattern here, right? That if you are multiplying an even amount of negatives, the answer will be positive. But if you are multiplying an odd amount of negatives, the answer will be negative. That's the pattern, and it alternates. Negative, positive, even, odd, right? That's the point of this right here. All right. Now for some actual problems. So again, I recommend you pause the video and try these. I have 6 of them displayed right now. These are the most normal PEMDAS problems on this page. I'm trying to teach you something with all these. If you'll notice, I know I'm doing more talking than you want me to, but notice how each of these problems, they're organized by rows. They all have the same numbers, but they're organized a little bit differently. See how that changes the answer? How does that affect the answer? So let's start with this first one right here. 8 minus 10, we got to do parentheses first, right? 8 minus 10, what is that? 8 minus 10 is negative 2, minus 5 plus 3 is 8, and negative 2 minus 8 is negative 10. That's the first one. Same numbers, different problem with different parentheses. So we need to do the parentheses first. And what you'll notice in the parentheses is you have addition and subtraction. But what did we say? The very first thing, the very first problems we had on this page was that if you're only dealing with addition and subtraction, work from left to right, even if that means subtracting first. So the first thing you're going to do here within the parentheses is 10 minus 5, which is 5. Then we have to do 5 plus 3, which is 8. 8 minus 8 is 0. Answer is 0. Same numbers, but here we have different parentheses. Remember in the last problem, the first thing we did was 10 minus 5. I have placed a second set of parentheses in this problem so that it forces you to do 5 plus 3 first, which is 8. Now we do 10 minus 8, which is 2, and 8 minus 2 is 6. So again, this top row of problems here all had the same number, but due to the different placement of parentheses, we had different answers. Same thing's going to happen here in the second row. All right, no parentheses, so we can do exponents next. Here's another thing. I don't know if you'll be able to see this. Some of you might be able to see this. This negative 2 times 7 is kind of like its own little island. And this 21 divided by 7 is also its own unit. And this 3 squared is also its own unit. All three of these can be evaluated at the same time because they're separated by subtraction. It would also be possible if they were separated by addition. So I'm going to do three things in the first step. Negative 2 times 7 is negative 14. Minus 21 divided by 7 is 3. Minus 3 squared, which is 9. Yes, you can do this. Now we just go from left to right. Negative 14 minus 3 is negative 17. Minus 9 is negative 26. Same numbers, but now we have some parentheses changing the order that we can do these things in. So let's do the parentheses first. 7 minus 21 is negative 14. Divided by 7 plus, all right, we talked about this, right? What is negative 3 with parentheses squared? That is going to be positive 9, positive 9. All right, now, as far as this section goes, this section contains multiplication and division, which means we work it from left to right. This section needs to go from left to right. Adding 9 will be the last thing we do. Negative 2 times negative 14. This is negative 2 times negative 14, not negative 2 minus 14 because of the parentheses, and that is 28. 28 divided by 7 is 4, and 4 plus 9 is 13. All right, here comes the last version of this problem. Same number, different parentheses. So inside the first set of parentheses, we have multiplication and subtraction. Multiplication and subtraction. We need to multiply first. So that's going to be negative 2 times 7, which is negative 14. Good. We can go ahead and knock out this exponent. This whole piece right here, right? That's what I was teaching you before. That's going to be, well, this right here is positive 9, but because of the additional negative, it becomes minus 9. All right, let's finish the parentheses right here. Negative 14 minus 21 is negative 35 divided by 7 minus 9. Negative 35 divided by 7 is negative 5 minus 9 gives us a final answer of negative 14. Okay, we're into the third row here, and the only thing weird about this row is these pies at the end. So I'm just going to throw those in there and show you what to do with them. Let's see what we can do first. We can divide first, we can square that as well, and we can take the absolute value of -1. All three of those things can happen in the first step. 12 divided by 6 is 2. 4 squared is 16, and the absolute value of -1 is +1. 2 minus 16, all we have left is to subtract. I know there's multiplication over here, but I'll show you what it is. 2 minus 16, that's -14. And this whole -9, 1 pi, well, multiplying by 1 doesn't change anything. So that's just going to be -9 pi. And the class I currently teach is a no calculator class. So we stop here. This is called leaving your answer in terms of pi. I'm not going to evaluate further because pi is an irrational number. So this is actually the cleaner way to do this. Just leave it like that. That is a good answer. Same numbers, but different order. Let's see what this gives us. We have parentheses right here. We also have absolute value right here, which remember I told you to treat as if it had parentheses. So we're going to do these two things in the first step. 6 minus 4 is 2, and 1 minus 9 is -8. All right, next we can move on to exponents, and I can also do the absolute value here. So that's going to be 12 divided by 2 squared is 4, minus the absolute value of -8 is +8, and the pi just tags on for the ride. The last thing you can do here is divide 12 divided by 4, which is 3, and we can't combine the 3 with the 8 because the 8 has a pi, but the 3 doesn't. So this is called leaving your answer in terms of pi. Just leave it like that. That's a solid answer. All right, here we go. Last one here. We've got 3 things going on in the parentheses, and then we also have another absolute value that is to be treated as having parentheses. So 12 divided by 6 is 2, plus -9 minus 1 is -10. 2 minus 4 is -2. And the absolute value of -10 is +10. So this last piece just becomes 10 pi. And the -2 squared, that's a negative times a negative, which is +4, and then plus 10 pi. And you leave your answer like that. You're more than welcome to type it in a calculator and see what the actual value of that is if it makes you happy. But that's the clean way to leave this. Just leave it in terms of pi. All right, the last row here, I'll show all of them. So if you want to try these out, try one of these out, you're more than welcome to. Just a heads up, these problems are going to introduce fractions. So two of them are. So let's do the first one here. Up front, we have a -4 squared. I can do that. I can also do 6 divided by 2, and I can also take care of the square root of 9 squared. I'm going to do all 3 of those things in the first step. -4 squared, notice how there's not parentheses here, so it's going to be -16. 6 divided by 2 is 3. I will need to multiply that by -7 plus, all right, 9 squared is 81, so this is going to be square root of 81. All right, what do I have to do next? I see some multiplication right here. Now that's going to be -3 times -7. Negative times a negative is a positive. So we have -16. It is going to be plus 21. Negative times a negative is a positive. Plus square root of 81 is 9. All right, now we just have addition, so we can go straight from left to right. -16 plus 21 is 5. Plus 9 is 14. Your answer here is 14. All right, next, same numbers, different order. We put parentheses on the -4 this time, which means it is now +16. The next thing I'm going to take care of is this 2 times -7. Now, Notice that this 2, because it has a plus sign in front of it, is positive. We're going to multiply that by -7, which means it will become a -14. So minus 14 divided by 6. I'm going to fix that. Divided by 6 minus, all right, in here we have this -9 squared. -9 squared with parentheses like that is going to be 81. Positive 81. Next, I need to take care of this division and I need to take care of this root. But here's where things get a little inconvenient. 14 is not divisible by 6. So we're going to switch this to a fraction bar, and I'm going to write 14 over 6 minus 9. Okay. Something new is going to, a lot of new things are happening with this problem. Here's another new thing. You can jump across these terms. So I can do 16 minus 9 next. And I'm also going to reduce this fraction. 4 and 6 are both, 14 and 6 are both divisible by 2. I'm going to reduce this fraction by a factor of 2 at the same time that I do 16 minus 9. 16 minus 9 is 7, reduced by a factor of 2 for 7 over 3. Now, I apologize. Well, I don't apologize. We have to subtract these. So we need to do a least common denominator here. So hopefully you're somewhat familiar with that. The only denominator here is 3. So by default, our least common denominator is going to be that 3. I need to rewrite this 7 so that it is something over 3. So you ask yourself, what over 3, what divided by 3 would give you a 7? Or directly, what is 7 times 3? And that is 21. So we're going to go 21 thirds minus 7 thirds. 21 minus 7 is 14. The answer here is 14 thirds. So that one was a little more involved. And this brings us to the last one, which is going to be just as involved. 4 squared up front is 16. Now, here we go. We have -2 times -6. -2 times -6. That's a negative times a negative. So that's going to be plus 12. Divided by -7 minus 9 squared again is 81. You're probably getting sick of this 81 here. All right, the next thing that needs to happen is this division and this root. But because 12 is not divisible by 7, we're going to switch to a fraction. Because that 7 is negative, it will change to 16 minus 12 over 7 and then minus 9. We can do the 16 minus 9, which is 7, minus 12 over 7. So the difference between this problem and the last is that this fraction is not reducible. In the last problem, I gave you a reducible fraction. Not so much here. Well, the only denominator is 7. So we need to rewrite this 7 so that it's something out of this 7. I know, a lot of 7s. So what divided by 7 is 7? Or directly, what is 7 times 7? And that is 49. 49 out of 7 minus 12 out of 7. Just do 49 minus 12, right? Just do the numerator. 49 minus 12 is going to be 37, and this is 37 sevenths. So, yeah, those are good problems right there. If you want to take a screenshot and grab those problems, so that way at least you have some examples of how to handle fractions. All right, cool. Onward and upward. We're just going to get bigger. That's all we're going to do here. It's still PEMDAS, still same rules apply. We're just going to get bigger and challenge ourselves a little bit more. So here you have two things going on that I instructed you to treat as having parentheses, and that's going to be the root right here, and that's going to be the absolute value right here. So before we can do anything else, we need to simplify the inside of these parts. -13 plus 7 is 4. I can do the 6 squared right now, which is 36. 2 cubed, -2 cubed is -8. 2 squared is 4. All right. This is ready to be square rooted, but this still needs to be simplified. So we're going to keep going here. The square root of 4 is 2. We can do the 36. Let me think about this. Can we do 36 divided by 12 right now? Yes, we can. That is going to be 3 times the absolute value of -8 plus 4 is -4. Now we're going to do the absolute value of -4, which is +4. Good. 3 times 4 is 12, and 2 minus 12 is negative 10. There you go. That's the whole problem. Same idea here. You just need to simplify the absolute value and the square root as much as possible first. So 2 cubed is 8, minus 3 squared is 9, minus 1, plus. All right, we have parentheses in the root that needs to happen first. Negative 7 plus 12 is 5. So all we did there was negative 7 plus 12. Back over here, we have 8 minus 9, which is negative 1. All right. Yeah, this is a great lesson too, in that these are absolute values right there, right? And then these are ones. So be careful with that. Plus 5 squared is 25. So it's kind of like you have your own PEMDAS problem underneath the square root. Good. Back over here, negative 1 minus 1 is negative 2. Plus, we can go 10 times 25 is 250. The absolute value of negative 2 is 2. And 250 minus 150 is 100. Look at that. Square root of 100 is 10. 2 plus 10 is 12. Answer here is 12. Oh, what a great problem. That is a great problem. Probably because I wrote it. But no, what good practice, right? If you can do a problem like this, you're good. I've never taught a college algebra class that does problems as hard as this. So if you can get these, man, you're golden. Excuse me. Okay. I'm going to stop explaining and just start doing a little bit more. Everything in parentheses, everything in the square root needs to be simplified first. Negative 15 divided by 3 is negative 5. We can do 2 cubed, which is 8. 60 minus 11 is 49. Negative 5 with parentheses squared is going to be 25. 4 plus 8 is 12. Square root of 49 is 7. 12 minus 7 is 5. 5 squared is 25. 25 minus 25 is 0. All of that just for a 0. Go figure. $25 minus 9 is 16. Three squared is 9. The square root of 16 is 4. Negative 8 minus 9 is negative 17. 4 cubed is 64. The absolute value of negative 17 is positive 17. 64 divided by 8 is 8. 8 times 2 is 16. Minus 17 is negative 1. The answer here is negative 1. We're bringing in fractions here. You have actual parentheses which need to be simplified first. You have absolute values which need to be treated as if they have parentheses, and then you also have a numerator and a denominator which again need to be treated as if they have parentheses. So these are the things that need to happen first. 3 cubed is 27. 13 times 3 is 39. 2 to the 4th power is 16. 22 plus 20 is 42. 27 minus 39, I'm going to do 2 steps in one. 27 minus 39 is negative 12, but the absolute value of that is positive 12. 16 minus 10 is 6. 42 divided by 7 is also 6. 12 divided by 6 is 2, minus 6 is negative 4. You've got everything here. Well, except exponents. Simplify, simplify, simplify. Negative 5 minus 6 is negative 11. Negative 7 plus 11 is 4. Negative 9 minus 15 is negative 24. Negative 2 minus 5 is negative 7. Plus 17 is 10. This right here, I'm going to finish this in one step. That double negative becomes a positive. Negative 1 plus 11 is 10. Divided by the square root of 4 is 2. The absolute value here, this is going to become positive because of the absolute value. Now I'm also going to reduce. 24 over 10 reduces to 12 over 5. Good. Now I'm skipping steps. I want this to fit on the screen. But notice here that I can cross cancel. 2 and 12 cancel to a 6. And a 10 and a 5 cancel to a 2. 2 times 6 is 12. So again, I apologize if I lost you there a little bit, but I'm not teaching you how to handle fractions in this video. You can find that in another, I'm sure I have it in another video somewhere. Oh, was that page? Wow. All right, there we go. Can I show 4 of them at the same time? There's 4 of them at the same time, so you can screenshot that if you want. If you want the top ones, here comes the top ones as well. So, good. Those are good problems worth studying, worth practicing. All right, this brings us on to evaluating expressions. Now, there's only one new thing here. All you got to do is plug in the numbers. Once you plug in the numbers, it becomes a PEMDAS problem. Then you just simplify. So, your new thing here, plug it in and then simplify. So, how do we do this? It says simplify this expression when x is 11 and y equals 2. So everywhere there's an x, I'm going to replace it with an 11. Everywhere there's a y, I'm going to replace it with a 2. So first we have 2. Y has a value of 2 minus x, which has a value of 11. X again, 11 minus 5 times 2. And there you go. This should start looking familiar, right? This looks like something we've done before. 2 times 2 is 4. 5 times 2 is 10. 4 minus 11 is negative 7. And 11 minus 10 is 1. The absolute value of negative 7 is 7. And the square root of 1 is 1. 7 plus 1 is 8. And that would be the answer there. All right, good. Here comes another one. Now we're going to evaluate this when a equals negative 2 and when b equals positive 2. So you just plug those numbers in. Now, word of caution, whenever one of your values is negative, use parentheses when you plug it in. So a here is negative. A has a negative value. Everywhere I plug that in, I'm going to use parentheses. So we have negative 7, 2, parentheses, negative 2, plus 5. All of that is under a square root. Minus 3. We're going to use parentheses here as well for the 2. All right, good. 2 times negative 2 is negative 4. Now, let's talk about this briefly right here. So, some people will try to multiply the 3 by the 2 first. It's tempting. I get it. But think PEMDAS. You have to do exponents before you do multiplication. So here you have to do 2 cubed first, which is 8, right? Do not multiply the 3 and the 2. There is no 6 there. There's an 8 here. All right, this becomes, we can do negative 4 plus 5, which is 1 minus 24. The square root of 1 is 1. And negative 7 times 1 is negative 7, minus 24 is negative 31. That would be the answer there. All right, here we go. We have an absolute value times the square root with some p's and q's. We're going to do this when p equals negative 2 and when q equals 3. So, due to the exponents, we're going to use parentheses. you're basically 99% of the time going to use parentheses when you plug numbers in. So P here is -2. We're going to want to cube that. Minus Q is 3, and we're going to square that. Times, we're going to cube. Here's an example when you don't need parentheses. You technically don't need parentheses for plugging in Q here. We could just write 3 cubed plus 9. Bring back the parentheses because P is -2. All right, -2 cubed is -8. 3 squared is 9. 3 cubed is 27 minus 18. -8 minus 9 is -17. Times 27 minus 18 is 9. The absolute value of -17 is 17, and the square root of 9 is 3. And 17 times 3 is 51. Wow, this one looks surprisingly easy compared to the last 3 we just did. So, all right. B is -6, C is -5. These are both negative. So 6 minus 4, plug in -5. Minus 11 minus 2. B here is -6. All right. 6. So here we have -4 times -5. Realize that that is what this is. This is not -4 minus 5. This is -4 times -5, which is +20. So this turns into a +20. Same situation going on here. This is -2 times -6, which is +12. This is 26 minus, look, 11 plus 12 is 23, which is positive. So the absolute values here are pointless. 26 minus 23 is 3. M is 2. N is -1. This is 10 over 4 plus 2 over 3. You say, hold up. Why did that just become a plus? That's because you have a negative and a negative here. Those two negatives, when they interact, they're going to multiply and become a positive. So, all right, good. Notice this fraction right here can be reduced. 10 over 4 is the same thing as 5 out of 2. So we got to go 5 halves plus 2/3. And again, this video is not about how to add fractions, so I apologize if you don't know how to do this. I teach this in other videos. You can find these online. This is going to be 15 out of 6 plus 4 out of 6. What in the... Yeah, hold up. Times 3 times 3. Good. Which is 19 out of 6. And that's the answer here. The value of u here is 4. And the value of v is -3. So 6 plus -3, that's just 6 minus 3. So we have 3 over 4 minus 6 minus 3 is 3/5 equals, this is going to be 15 over 20 minus 12 over 20, which is 3 over 20. Don't complain in the comments. Oh, he goes too fast, right? No, this video is not about subtracting fractions. You can find that in another video. So if you don't get these fraction ones, that's fine. All right, good. Okay. This brings me to something that I would be willing to bet I am the only person, I'm the only professor, instructor, teacher, YouTuber to ever do this. And this, I bring this up, I prepared this page because some time ago I made a YouTube short explaining why PEMDAS was some universal truth, like the law of gravity. And I was corrected. I was quite humbled in the comments. And I was taught that PEMDAS is not some absolute truth. In fact, it is arbitrary. The order of operations is arbitrary. We could have chosen a different order of operations. Now, I didn't look up, but there's probably some historical significance to why it is PEMDAS. But it didn't have to be that way. And so I'm going to read this to you. This page is designed to help you think outside the box. You will never be tested on an alternative order of operations. You will never see this in any other class. This is just meant to stretch you. The order of operations, PEMDAS, although nearly universal, is arbitrary. This means that the order could have been anything. Granted, there is probably some historical significance to it. Regardless, let's evaluate some problems using different orders of operations. So this is purely just for fun. If you're just watching this video because you need help with math, I don't want to confuse you, but if this stuff does fascinate you, stick around. Here are some alternative orders. We have, well, PEMDAS, but then we have SADMIP, DASPIM, and MADPIS. So, yeah, let's just see what happens here. If we evaluate this according to PEMDAS, we would multiply first, and then we would add. So according to PEMDAS, the answer to this is 13. But what if instead we do SADMIP, which says that you need to add before multiply? So 3 plus 2 would be 5 times 5 is 25. Now again, I do not want to confuse you. The answer is 13. But what if? What if the order of operations was backwards? Then the answer would be 25. Kind of trippy. What if the order of operation was DASPIM? Well, let's see. This one also puts addition before multiplication, so that would be 5 times 5, which is 25. And MADPIS, which puts multiplication before addition. This would be 3 plus 10, which is 13. So we kind of have 2 of each here. And the reason why there's 2 of each is because these problems only had 2 operations, right? They only had addition and multiplication. So obviously there's only 2 possibilities there. You can add first and then multiply, or you can multiply first and then add. So, my goodness. All right, the next one's going to get a little more interesting. In fact, I'm going to rewrite these acronyms below so we can see them. All right. So if we do this according to PEMDAS, we need to do the exponent first. This would be 75 minus 25 divided by 25. And then we would need to divide, so this would be 75 minus 1. Finally, we can subtract for an answer of 74. That is the correct answer. If you have this on a quiz in your high school or college class, make sure you do it that way. But what if the order of operations was reversed and it was SADMEP? According to this, the first thing we would need to do is subtract. So 75 minus 25 is 50. The next thing we would need to do is divide. 50 divided by 5 is 10. Then we would do the exponent. 10 squared is 100. So again, kind of crazy, right? If we reverse the order of operations, you get a different answer. All right, this is DAS. Whoa, I didn't copy that one right. The last letter is supposed to be M. Let us fix that. EM. So according to this, we need to divide first. Interesting. So this would be 75 minus 25 divided by 5 is 5. And then we need to subtract. So, wow, 75 minus 5 is 70. And then we would do 70 squared. Well, don't be scared of that. 7 squared is 49, so 70 squared is 4,900. Wow, what a difference. You know, how changing the order, the first problem, and the correct answer is 74. Then it turned into 100, but man, 4,900, what a difference. What a difference. What about this last one? Let's check out this last one. Okay, so we have subtraction, division, and exponents. According to this, division needs to happen first. So this would be 75 minus 5 squared. And then the exponent needs to happen, so 75 minus 25, and then finally we can subtract for an answer of 50. Wow, fascinating. So there we go. Unlike the first row, which had 2 of each answer, this one actually had 4 distinct answers. It's almost like someone planned that. All right, and again, I'm gonna pull these down so we can actually read them. Last one here, we have exponent, division, and subtraction. According to PEMDAS, which is what you will do in your class, we do exponents first, then we can divide, and then we can subtract. So the answer here is 2, right? That is the correct answer. But what if the order of operations was reversed? Here we would subtract first, so 4 minus 2 is 2. Then we would divide. Now, this is a little bit weird. I'm going to rewrite this as 2 caret mark 4 divided by 2. That caret mark is the same thing as an exponent. But I want you to see here that we're actually going to divide 2 from the exponent 4, right? So this becomes 2 caret 2. 4 divided by 2 is 2, right? And then we can do the exponent. This is 2 squared, which is 4. So here we get a different answer of 4. Okay, how about this one? We need to do the division first, but notice here that we're going to divide 4 from the exponent of 4. So I'm going to rewrite this problem as 2 caret mark 4 divided by 4 minus 2. So you can see we have 3 different operations: the exponent, the division, and the subtraction. According to DASPEM, you need to do division first. 4 divided by 4 is 1. And then we need to do subtraction next. That's 1 minus 2. So this becomes 2 to the negative 1, 2 to the negative 1, which is 1/2. Wow, that's pretty cool. This order of operations gave you a negative exponent, which means reciprocation. And then lastly here, I'm going to rewrite it with the caret mark. Let's see here. Looks like division is first. So 4 divided by 4 is 1. So we have 2 to the first power minus 2. Then we need to use the exponent. 2 to the first is just 2. And then subtraction, which is 0. So, man, I get it. You probably don't think this is that cool. You know, if you're watching this, you think this is cool. If you're still here, you're fascinated by this. But, yeah, we could have picked a different order of operations and we would be getting different answers. But PEMDAS is the right one, or maybe you live in a part of the world where they use BODMAS or GEMMA, but they're the same order, just with different words. But yeah, I hope this video helped you. I hope it broadened your understanding of PEMDAS and the details involved in it. But it is necessary, right? We have to have this universal agreement as to how we solve problems, and PEMDAS is it. So, good. Thank you for sticking around, and we'll see you in the next one.